Good morning, Team PW. Welcome to Visakhapatnam. Myself, Dr. Rajesh Kumar, Faculty of Mathematics, dealing with IIT JEE pattern. I am working with one of the corporate institute from the last couple of years located at Visakhapatnam. I completed my doctoral degree from the Geetham University with a specialization of numerical analysis. I also did my master's and a B.Ed from the Andhra University. I have a good experience to train the students to get placed in best IITs and better NITs. My strength in this system is that I can make any kind of a student feel comfortable and a confidence in my domain. Thank you. Here I want to start uh, my topic from the definite integration, name it as integration as the limit of a sum. So that's my topic today, integration as the limit of a sum. Sir, from the fundamental theorem of calculus, at the basic stage, we introduce integration is a reverse process of differentiation. It is also fact that integration is nothing but the summation, or I can say adding the things. So using this phenomenon of concept of integration is a summation or adding, we can calculate the area of some irregular figures and the volumes and also some mathematical quantities. So here I want to ping you some point. When I am calculating the areas, we know the area of the circle, you know the area, we know the area of the rectangle, we know the area of the triangle. But using this particular topic, we can calculate the area of some irregular figures too. To understand this entire concept, I'm coming with a certain explanation. Let y is equal to f of x be a continuous curve. You can see on the graph. Let x-axis and the y-axis. And suppose this is the graph. It is in between x is equal to a and x is equal to b. While I want to calculate the area, while I want to calculate this entire area, it is like we need to divide this entire area into rectangles, like let it be n number of rectangles here, like this is the first rectangle, second rectangle, third rectangle, fourth one, and well, it is a fifth one. So if I adding all the areas of the rectangle individually, you will get the area bounded by the curve y is equal to f of x in between a and b. Not exactly, well, I can say it is approximately. So to understand this topic very clearly, I want to give a better explanation on this. Let this is x-axis and y-axis, and y is equal to f of x. Y is equal to f of x is the curve, and well, I can say it is between x is equal to a and x is equal to b. As I mentioned you before, I need to divide it into the certain number of rectangles, the 1 and the 2 3, 4, and so on. Let it be n number of rectangles, and I need to mention it is of a equal width. It is of a equal width. Now let y is equal to f of x be a real valued continuous function. It's a real valued continuous function. When I divided it, I should name it as, suppose it is x0, x1, x2, x3, x4, and so on. This is xn minus 1. Well, it is xn. And h is equal to b minus a by n. That's a width. This part is called width. So when I saw this particular figure, in fact, I need to calculate the area, right? So to find the area bounded by f of x between x is equal to a and x is equal to b, and I can say that area as a capital A, suppose. I can say that area as a capital A, suppose. Now I'm talking about the case 1. Look at on the figure. When I want to make it as a rectangles, first join these, like, see, I can shade. This is the one rectangle. Like, when I calculate the area is equal to length into breadth. Anyway, breadth is equal to h, there is no doubt at all, and I need to calculate the length. And using the graphs, I can calculate this point is, what is that point? Is it not x naught comma f of x naught? That means this point is not f of x naught, or what? This is f of x. So when I'm calculating the areas, the first area is equal to f of x naught into h, and the second area, I can say it's a a1, a2. Second area, when I'm talking about the second area, you can see on my screen, this is the second area, right? There, its area is equal to length into breadth. I can say this is the breadth and this is the length now, right? So that I can, using the point, I can say it is x1 comma f of x1. So when I come to the second area, it is called f of x1 into h, and so on. When it comes to the nth area, it is, when I'm talking about the nth area, look it on my screen, look it on my graph, please. So this is the thing. When I'm talking about the nth area, I need to take this as a breadth and this as a length. And the length is nothing but f of xn minus 1, in fact. That is equal to f of xn minus 1 into h. Sum up, add it. So the area is equal to, here I'm writing smaller parts. I'll say why I wrote smaller parts. Is equal to, if I take h common, it is called f of x naught plus f of x1 plus f of x2 and so on, f of xn minus 1. Let it be equation 1 for a while. Now when it comes to the second part, case 2, do remember the case 1. It is h into f of x naught plus f of x1, like that. When I'm talking about the case 2, my dear, case 2, again, calculate the areas a1, a2, a3. But when we are calculating the first area, when I'm calculating the first area, look at the graph. I'm drawing like this. This is the second one. And here one more, here one more, here one more, like this, here one more, like this, here one more. That means when I am calculating the first area, so when I'm calculating the first area, my area locates this now. This is the first area. There, breadth any cost h, there is no doubt at all. When I'm talking about the length, look at the length. The length is this, it is nothing but f of x1. I guess I'm clear. So that is equal to x h into f of x1. Second one, when I'm talking about the second area, this is the second area I need to calculate. Their area is equal to length into breadth. Any cost, this is h. We are repeatedly saying you. When I'm talking about the length should be this length, no? It is nothing but h into f of x2 and so on. It is equal to h into f of x3 and so on. When I'm talking about an, it is h into f of xn. It is h into like I can say that the total area is equal to, I'll write it as a largest, is equal to h into f of x1 plus f of x2 and so on plus f of xn. Yes, f of xn. Let it be equation 2. Now the doubt arises. What before in the case 1 you wrote areas with the smallest. Now you wrote areas with the largest. What is the difference between them? So try to understand when we are talking about the smaller, we consider this area. When we are talking about the larger, we consider this area. In fact, the required area is exactly between them. I'm not saying it is exactly half of them. It is in between. So required area is equal to, I'll keep the diagram like that. That's a graph like that. And the rest analysis I'm doing on my screen. So what is a final statement I can write? Area of smallest less than or equal to required area less than or equal to area of a largest. In fact, I can use smaller rectangles and the larger rectangles. So I'm picking you again. I'm saying you again. What when I'm talking about the case 1, I consider this rectangle. Don't be confused, please. When I'm talking about the second part, I consider this rectangle. In between, that's a fact. In between the area is, we need to calculate the required area. In the same way, when I'm talking about the last rectangle, I can say it's the nth rectangle. When I'm talking about the smaller area, we calculated this part. When I'm calculating the larger area, we consider this part. But in fact, what we required middle part, no? The required area is here. I cannot say it's exactly half of that. It definitely lies between the smaller and the larger. So it is equal to h into, here when I'm starting with the smaller, I consider with this f of x0 plus f of x1 plus and so on plus f of xn minus 1. I guess it ended with here. It's a less than or equal to required area less than or equal to largest. What's a larger? F of x1 plus f of x2 and so on plus f of xn. Yes. Now, my consideration is this. What is this? It is a width. How much it is? H is equal to b minus a by n. What it indicates? I divided the length between a and b into n equal parts. If suppose I divided this entire length into, if divide this entire length into 5 parts, you'll get this much length. If I divide this entire part into 20, you can see the width is decreasing. If I divided this only entire length into 1000 parts, the width is very much decreased. Array, indirectly I'm saying when n tends to infinity, what you can say? When n is equal to 5, this is the width, suppose. When n is equal to 10, this is the width. When n is equal to 100, definitely this is the width. That means the width is tending to 0. So the same concept when I am applying on my graph, once let it be x-axis and y-axis. As usual, this is my graph and it is in between A and B. I say this is x naught, this is xn. Now I want to divide it into infinite number of intervals. No, that means the width is equal to 0. Sir, when the width is equal to 0, it will be like this. That means shading. Like this, you will get the entire area. No, so when the width is like this, you differentiated. This is the lower rectangle. This is upper rectangle. When the width is this much, how can you say which one is a lower, which one is a larger, which one is a smaller? That means when I am saying n is tending to infinity, sir, I'm repeating again. When the graph is like this, that is this much is the width. We said this is the lower rectangle and this is the upper rectangle. When the width is this much, what is the lower rectangle, what is the upper rectangle? We cannot differentiate. That's why when n tends to infinity, area of smaller rectangles is equal to required area is equal to area of larger rectangles. That means when n tends to infinity, that is indirectly h is equal to 0, area is equal to limit n tends to infinity h into f of x naught plus f of x1 plus f of x2 and so on plus f of xn minus 1. That is equal to limit n tends to infinity h into, it can be written as a f of a plus h, f of a plus 2h, like h much distance we segregated, f of a plus nh or n minus 1 into h, anything is fine. In fact, n minus 1 into h. That is equal to limit n tends to infinity, h is b minus a by n into sigma f of a plus n minus 1 into h. At infinity n minus 1, there is so much difference. That's why I can write it as a nh. That is equal to limit n tends to infinity b minus a by n into sigma f of a plus n into b minus a by n. In the special case, yet a is equal to 0 and b is equal to 1, we can write area as a, I'm writing in the next slide. Yet a is equal to 0, b is equal to 1, area, it can be written as an integral 0 to 1 f of x dx. First definite integration representation is equal to limit n tends to infinity sigma r is equal to 1 to n 1 by n into f of r by n. This is the original representation or the special case, I can say. Okay. Only the thing you understood at the beginning, I said the differentiation sorry, integration is a reverse process. Integration is a reverse process of differentiation. Integration is also called it as a sum or adding up. That adding up, the only the term which gives the idea to calculate the area of this irregular figure. That's what. So now I want to give a certain examples on this particular topic. And the example number one, if Sn is equal to 1 by 1 plus root n plus 1 by 2 plus root 2n plus 1 by 3 plus root 3n and so on plus 1 by n plus root n square, then they are asking limit n tends to infinity Sn. Kindly understand, they gave a finite sum. They're asking what it will become infinite sum. So it can also be written as a limit n tends to infinity sigma 1 by r plus square root of Rn, where r is moving from 1 to n. That is equal to limit n tends to infinity. If I take n common, it will become 1 by n into, it will become 1 by n into sigma r is equal to 1 to n 1 by r by n plus square root of r by n. Using the analysis what we did in the last slide, it can be written as a integral 1 by x plus root x into dx. Still what left? Limits, no? Clearly r is moving from 1 to n. R by n moving from 1 by n to z, n by 1 to 1. When n is tending to infinity, r by n is moving from 0 to 1. Here r by n we replaced with x, so x is moving from 0 to 1. Now it is enough to calculate integral 0 to 1 x plus root x. This can be evaluated by putting x is equal to t square, and we can evaluate that particular integration. And I'm coming with an example number 2. It is limit n tends to infinity sigma r is equal to 1 to n r by 2r square minus 7rn plus 6n square is dash. That's the thing they gave. Is dash solution. They gave summation with an infinite limit. It indicates that the integration. So it can be written as a limit n tends to infinity sigma r equal to 1 to n sigma r equal to 1 to n indirectly divided with n square. 1n is here, 1n is here. It's a 2 into r by n whole square minus 7 into r by n plus 6. In the previous question, I mentioned you the entire content can be written as an integral. The entire content can be written as an integral x by 2x square minus 7x plus 6 into dx. Well, the issue with the limits, r is moving from 1 to n, r by n moving from 1 by n to 1. When n is tending to infinity, it is moving from 0 to 1 into dx. So integral 0 to 1 x dx by this factorization, it can be written as a 2x into 2x minus 3. This can be evaluated using partial fractions. A by x minus 2 plus b by 2x minus 3 into dx with the limit 0 to 1. That is equal to 2 into integral 0 to 1 dx by x minus 2 minus 3 into integral 0 to 1 by 2x minus. This mathematical part belongs to partial fractions. Now this is a log x minus 2. This is a log 2x minus 3 by dx. You can evaluate it. So thank you very much.